Now, a couple of things that you probably want to make a note of. If you look in this box, number one, I'm seeing a lot of formulas. This is going to be a really helpful sheet when you test. But number two, you sort of need to understand the difference between all these terms so you'll know what it is you're actually looking for or what you're doing. And the first thing that I want to make sure you know is if you see this word marginal as it's relating to business, it's just the way that they ask you to find the rate of change. Okay? So if they're looking for marginal cost, it means you want to find the derivative of the cost function. Now, cost simply means what it is that you have to spend to produce whatever it is you're producing, right? Okay, so it has nothing to do with what you sell it for. It has nothing to do with how many you sell. It's just purely, if I'm making this, what have I spent to make this many? Okay, whether I sell one or whether I sell 100. The revenue, on the other hand, is going to be, in fact, can you guys tell me, what does revenue mean? Money you take in. That is an important part of what you're going to be concerned with in business. You know that you have costs for making something, but when you sell them, you will have revenue. Now, obviously, if you have any business acumen at all, which one do you want to be bigger? Well, we're going to want to have a profit, and the profit happens when which one's bigger, the revenue or the cost? We want more revenue than we want cost so that we will have a profit. And this is simply explaining if I take my revenue and subtract my cost from it, that's going to show me what my profit is. To a certain extent, even on filling out tax forms, you probably see areas where you're kind of doing this. If you're taking off deductions, you only have to pay tax on what might be considered to be profit. My husband is self-employed. So that's a really key feature for us, is keeping up with what are valid business expenses. We want to make sure that we deduct every cost we can so that there will be hopefully, a smaller amount of tax we owe. Sales are great. You want to have good sales, but you got to make sure in order to minimize your tax liability that you take advantage of all of the deductions you can for those cost expenses, okay? And so the same is true, obviously, in a much larger business setting. Now, this is simply explaining that if these are how you find your cost, your revenue, and your profit functions, if it asks you to find marginal cost, take the derivative of the cost. Marginal revenue, derivative of the revenue. Marginal profit, I would probably, you could take the marginal revenue minus the marginal cost. I'd probably just take whatever the profit is that I most likely have already found and take the derivative of it. It's going to give you the same thing. Now, in addition, you're going to see them talk to you about finding things like average cost. Now, think about it for a minute. Average cost simply means if I know what my total cost was to produce, let's say, 100 radios, could I figure out what the average cost per radio is? Absolutely. I would just take whatever the total cost is, and I would divide it by how many radios I made, okay? And the way we designate that using symbols is we put this bar on top of capital C. Is there anything involving a derivative in this? The answer is no, because I don't see the word marginal. I'm just taking whatever the total cost is divided by the number of items, and that's going to give me the average cost. You might have to find the marginal average cost, though. And if you do that, you have to find the average cost first, then take the derivative of the average cost. Make sure, pay attention to the order these words are in. Marginal is telling you to take the derivative. It's going to be the derivative of whatever comes after it. So I've got to get the average cost first, then take the derivative. And the same is true for revenue and for profit. Okay, so that's a little background on how to read the terminology. Now let's look at a few example problems and see if we can put it into practice. Okay, if this is my cost function, 6,000 minus 40x plus 0.006x squared, and this is my revenue function, how am I going to find the marginal cost function? All I have to do is what? Take the derivative of just the cost, right? In other words, I don't do anything with the revenue on this one. I just want marginal cost. So I'm going to need to find C prime of x. Now, you may notice this is not written in descending order. Doesn't matter when it comes to finding derivatives. If you wanted to rearrange it, you could, but I think let's just go term by term. What's the derivative of 6,000? 0, because it's a constant. Second term is negative 40x. So what do you get when you differentiate that? Negative 40. And then differentiate the last term, 0.006x squared. What am I going to need to do with that? Good. Take that 0.006, multiply it times 2. That's going to turn into
0.012.
You got it, 0.012, and what comes after that? X to the first. Very good. That is my marginal cost function. You're done. Now, can I find the average cost function? All I have to do with average cost is what? If you look back up here, average cost is found by doing what? You got it. I'm going to divide it by however many I produced, which is my x. That is my C bar of x. No derivative involved here. This is just taking my cost function and dividing it by x. And my recommendation is I would do this term by term. Go ahead and write your cost function, but then divide each individual term by x, and we'll clean this thing up one piece at a time. Okay? So my average cost function, is there anything to clean up on this first one? No. It's just 6,000 over x. Now, what do you get when you clean up negative 40x over x? What can I do with the x's? I sure can. So that's a minus 40. And then how do I clean up this last term? So if I have an x squared on top and an x on bottom, that's going to give me what? X to the first on top. So I have 0.006x. That is my average cost function. So if all I wanted to know is what's going to be my average cost if I make 200 of these units, I can plug that in and I will know exactly what it is. Okay? Good. Now, we hadn't done, well, we have one more thing to do with our cost function, then we're going to talk about that revenue function. So if I ask you to find the marginal average cost function, I'm going to be doing what? Marginal tells me to do what? I've got to take the derivative of what? The average cost function. So that C bar, that's what I'm taking the derivative of. I'm finding C bar of x. Now, I'm going to copy down what we just got for the average cost function. We had 6,000. It was over x. Now, since I know I'm going to be taking the derivative, do you think it's a good idea to leave the x in the denominator, or do I want to go ahead and rewrite it? As what? 6,000x to the negative 1. The x to the first on bottom becomes x to the negative 1 when I take it to the top. And then we had our minus 40, And then we had our plus 0.006x, and that's what we're going to be taking the derivative of. So tell me what you get when you take the derivative on this first term. Negative 6,000 x to the, what's my new exponent? Good. Subtract 1 from a negative 1, that gives you a negative 2. What happens if you take the derivative of negative 40? You get 0. Excellent. And then what do you get when you take the derivative of 0.006x? Plus 0.006. This, if we write it with a positive exponent, that would be the only other cleanup thing to do, which is negative 6,000 over x squared plus 0.006. This would tell us the rate of change per item for the average cost. So in other words, if I wanted to know, how much would I expect my rate of change to be if I'm making 200 units? Maybe I know I'm making a profit with 100 units. Maybe I want to see with 200 units, is my rate of change still increasing? Am I still adding to my profits? Or is it decreasing? Am I actually not making as much if I create more? I mean, there's some valid things we might be able to find from that if we wanted to use this formula. Now, let's go through the same process, but this time let's use the revenue function. So let me remind you what our function was for revenue. It has fewer terms. It was 10,000 x minus 200 x squared. So if I want to get the marginal revenue function, what do? What is the word? Good. Take the derivative of the revenue, and that's going to be what? Actually, don't I have an x on this first term? So I'll still have what in front? First term becomes what when I take the derivative? 10,000. Good. And then if I take the derivative of minus 200x squared, it becomes minus 400x. All right.
Is it minus or?
Well, there's a minus sign in front of the 200. Remember, a sign in front of the number stays with the number. So I can think of it as a negative 200, or I can think of this as plus a negative 200, and you can write it as plus negative 400x, but there better be a minus sign there.
Then I have another question.
Yeah.
Does it have to be written like that, like when you're doing, like you want to keep it in some order, or can you like switch it?
If you want to reverse the order, that's perfectly okay. You can put it in descending order if you want. And I think what you're going to find is sometimes they have it in descending order, sometimes they don't. So if that's sort of one of those stickler things for you and it really bugs you that it's not in descending order, feel free to rearrange it. Just make sure you don't mess up signs if you rearrange, because it's going to have to start off with a negative 200x squared plus 10,000x if you turn it around. Okay, how would I find my average revenue function? Average means I do what? Average is the one that has the bar. So I'm taking R bar of X. Now, how do you do it? Take your revenue function and take each term, put it over X. Very good. So my revenue function was 10,000X minus 200X squared, and I'm going to divide each one of these terms by X. Now, when I do that, in the first term, X is canceled, don't they? And in the second term, an X squared on the top does what with an X on the bottom? Cancels out the X on the bottom. It's going to become X to the first on the top. So what is my average revenue function? You got it, 10,000 minus 200X. how would I find the marginal average revenue function? Of what we just found, right? So my average revenue function, when I take the derivative, becomes my marginal average revenue function. So I'm going to look right over here at this average revenue function. What happens if you take the derivative of 10,000? It's 0 because it had no variable in it. What's the derivative of negative 200x? Oh my goodness, look at that. Your marginal average revenue function is a negative 200. Sounds like somebody's losing money to me. Or at least they're bringing in less money. Now, the profit function we find by doing what? Because typically they don't give you the profit function, you have to find it. And profit is found when you do what? Good, revenue minus cost. Okay, so our revenue function was the 10,000x minus the 200x squared, right? And then we want to subtract the cost function, which was the, wasn't it 6,000 minus 40x plus 0.006x squared. Ooh, ran out of room. Okay, let me see if I can scoot that over a little bit. Okay, because of the subtraction sign, be very careful that you remember to do what? Yeah, distribute through, change those signs. So what I'm going to do is make that a plus. If I change the signs in here, that becomes a negative 6,000, that becomes a positive 40x, and that becomes a negative 0.006x squared, right? Okay, so let's see what we end up with when we put all of this together. And since you kind of mentioned descending order, let's write our answer in descending order. If we were to put together our x squared terms, I've got a negative 200x squared and I've got a negative 0.006x squared. What is that going to be if I put that together? Yeah, negative 200.006x squared. So I've taken care of this and this. Do we see two different x terms? I do. I've got 10,000x plus 40x. So would you agree that's 10,040x? So that and that. And then what else do I have? Yeah, minus 6,000. That is my profit function. So now that I've found it, what would we do to get the marginal profit function? Take the derivative, p prime of x. Okay, what do you get if you take negative 200.006x squared and differentiate? It's going to be negative, right? Negative 400.012x. Excellent, because I took this exponent, pulled it down, multiplied it times the coefficient, and then my new exponent is one less than what I started with. So that's why I have that. How do you differentiate 10,040x? Just becomes 10,040. And what happens to that minus 6,000 on the end? Becomes 0 when I differentiate. So there is my marginal profit function. How do I find the average profit function? That's the p bar of x. I've got to take the original profit function, which we found to be negative 200.006x squared plus 10,040x minus 6,000, and then we do what to each term? Over x. Divide each one by x. And that's going to give us x squared on top, x on bottom. The x on bottom takes out one of the x's on top. So that's a negative 200.006x for the first term. What happens in the middle? Yeah, the x's cancel, so I have a plus, oops. $10,040. And the last term, do we want to leave the x on bottom when we write it? We can. If we're going to have to find the marginal average profit, then we can move it up to the top. So if I just write it on this problem, I'm probably going to want to leave the x on bottom so that all of my variables have positive exponents. But we remember we have to rewrite before we could differentiate. If we look at the next problem, accidentally bumped back to the, guess what we find? The marginal average profit, which means we'll have to take what we just found and differentiate it, right? So that average profit function was a negative 200.006x plus 10,040 minus, and instead of putting it as 6,000 over x, we can write it as minus 6,000 what? X to the negative 1. We can bring that x to the top as long as we give it a negative exponent. Now we'll differentiate this. So we're finding the derivative of the average profit function. All right, what does that first term become? Negative 200. Well, I don't think I have a square on this exponent, do I, for average profit? So it's just negative 200.006. There we go. So negative 200.006. What happens to that term in the middle? 10,040 just becomes 0. And then tell me what this last one is going to become. Good. The negative 1 times the negative 6,000 becomes a positive 6,000, but it's x to the what power? Negative 2. I have to subtract 1 from negative 1, which gives me a negative 2. So if I clean this up with a positive exponent, that's negative 200.006 plus 6,000, how do I write it? Over x squared. Okay, so are we getting more comfortable with being able to move negative exponents and do what we need to do? Good job. So let's look at a few real-world problems and see if we can figure out how to apply this. The total cost in dollars of manufacturing X units of a product is this. We want to find the average cost per unit if 300 units are produced. Okay, so you guys need to tell me if I'm looking for average cost, what am I going to need to find? What formula? C bar. Very good. Average has the bar on top. In fact, if any of you have taken statistics, that ought to look familiar because X bar was the symbol we used for the mean, which is another word for finding the average. So if I want to find the average cost, I'm going to take this cost function and do what with it? Put everything over X. Good job. And that's going to mean that the C bar of X is 10,000 over X plus what? Yeah, those x's cancel and I just get plus 15. But the specific question it asked me to find is the average cost per unit if I'm making 300. So what would I have to do now? Plug in 300 into this equation I just found. So C prime, or I'm not C prime, C bar of 300 means I've got 10,000 that I'm going to divide by 300. And then I add 15 to it. Now that sounds to me like you might want a calculator because 10,000 divided by 300 is going to give you something that's decimal in nature. And since we're talking about money, Let's round this to the nearest penny. And what are you going to end up with? $48.33. That is the average cost per unit if you're making 300 of whatever this product is. They didn't tell us what it was. Okay? So that might be something that would be important to know. Now, for the B part, we're supposed to find the marginal average cost at a production level of 300 units, and then we'll explain what that means. So if I need the marginal average cost, I have to do what? Take the derivative of this function we just found. So we want to take the derivative of C bar of x. Now, that means when I take the derivative, I probably will want to think of this as 10,000 x to the -1, right? Plus 15, because instead of having the x in the denominator, I'm going to need to write it as x to the -1 when I differentiate. What's that going to give me? Yes, because that -1 times 10,000 is a -10,000. But what happens to my exponent? X to the -1 becomes x to the -2. Good, because I have to take 1 away from my exponent when I'm differentiating. And what happens to that plus 15 on the end? It becomes 0. So this is the same thing as a -10,000 over x squared. So now, if I want to find what is that marginal average cost when I'm producing 300 units, I'm going to plug in 300 for x. And that definitely looks like a calculator issue. Now, see what you can tell me you get when you clean this up. And was it a positive 11 cents or a negative 11 cents? If I have a negative 10,000 on top, when I square 300 on the bottom, that's positive. Negative by a positive is a negative. That's a negative 11 cents. Now, what does that mean? What's happening when you're producing 300 units? Well, now, if we were talking profit, I would say yes. But this is giving you the marginal average cost. So is it good if the cost is negative? That means that the expense is going down to make the next unit. So what we could say is at the production level of 300 units, the next unit decreases 11 cents in average cost. So in other words, if I make more than 300, if I make 301, each one of them costs me 11 cents less to make per unit. So if you look at the C part, it says use the results from A and B to estimate the average cost per unit if you're making 301. Now, you could do it a couple of different ways. What do you think might be a quick way to figure it out? If I know that the average cost of 300 units is $48.33, which I just found in A, and I know if I make another unit, my average cost should decrease by 11 cents, what's going to be the average cost on the 301st unit? Well, I could take what it costs to make 300 units, yeah, and subtract 11 cents from it, which would be $48 and how many cents? There you go. Because that average cost was decreasing if I increased production. Okay? One more, and then we'll be done with these notes. So the total cost and revenue in dollars for the production and sales of X units are given respectively by these two functions. So we've got a cost equation, we've got a revenue equation. So let's talk profit for a minute, because that's sort of the bottom line. We want to know if we're going to be profitable. Can you find the profit function? And everybody says yes. By doing what? How do you find profit if you know cost and you know revenue? Subtract revenue minus cost. As long as I'm bringing in more money than I'm spending, I should have a profit. So my revenue function was 300x minus 0.03x squared. And we're going to subtract from that this cost function, 32x plus 36,000. Okay? Clean that up. Do you want to put it in descending order? Does that make everybody more comfortable, or do you care? Let's try putting it in descending order. I'm going to do the same thing we did a minute ago. Because of the minus in front of this second parentheses, I've got to do what? Distribute. So that's going to become a plus. That's going to become a negative. That's going to become a negative. Now let's add these together. And I'm going to put these x squared terms. Actually, let me do it this way. Let's put the x squared here. Actually, there's only one x squared, isn't there? So we're going to have a negative 0.03x squared. Now if I put together the x terms, here's a negative 32x and a positive 300x. If I combine those, I get what? Plus 268x. And the only thing I have left is this little guy on the end that's a minus 36,000, right? That is my profit function. So we've done the A part. Now, can we determine the actual cost, revenue, and profit from making and selling 101 units? What do you think? By doing what? Yeah, to these equations. Have we had to take a derivative anywhere yet? No. So if I want to find the cost of 101 units, I'm going to go to that cost function, and I'm going to put 101 in for x. And what do you get back? And remember, this is money, so we'll round to the nearest penny if it doesn't come out to be a whole number. It's $39,232. You are exactly right. Okay, now to get the revenue for 101 units, we plug in 101 to the revenue function. So 300 times 101 minus 0.03 times 101 squared. And that's going to equal how much? Good, you're exactly right. It's $29,993.97. Now, I should be able to do a quick visual. Am I making a profit? My revenue is smaller than my cost, but I can find out exactly what that profit is if I subtract these two. I have to do revenue minus cost, so it's $29,993.97. minus the $39,232. The other thing I could do is I could actually plug 101 into the profit function, but this is going to be faster if I do it this way. And I get what? I know it's negative. You got it. Negative $9,238, and I believe it's 3 cents, right? Okay. So I am losing money at the production level of 101 units. Okay? Now, if I wanted to know the actual cost, and keep this in mind, this is the total cost of producing 101 units. If I want to know the actual cost of the 101st unit, then I would need to do what? If I knew how much it cost to make 100 units, could I subtract that from what it costs to make 101? Wouldn't that tell me the actual cost of the 101st unit? I could. What we're actually doing here is we're kind of seeing if we don't come up with the marginal functions, we could actually do it this way. So let me show you on C. Actually, before we do C, let's do this. Let's do the cost of the 100th unit, the revenue of the 100th unit, and the profit on the 100th unit. I'm going to give you a second to work those out. So tell me, if you plugged in 100 into that cost function, what did you get back for the dollar amount? The total cost of making 100 units was, and I know it should be less than the $39,232, because that's how much it cost to make 101. So what'd you get? $39,200, right? Good. What was the actual revenue that you make for 100 units? $29,700, very good. And then if you found the profit on 100 units, it was, I know it's still got to be negative, but it was negative what? Negative $9,500. So here's how we could determine, without using derivatives, the actual cost of the 101st unit. I could take the cost of the 101st unit, which was $39,232, and subtract the $39,200 from it. And what do I see was the actual cost of the 101st unit? $32. If I do the same thing on revenue, that's $29,993.97 minus 100 units cost $29,700, and I get right. So that's how much revenue I'm going to bring in on the sale, and my profit was a negative $92,3803, because that's what it was on the 101st unit, but then I subtract from it a negative $9,500. So what I'm actually doing when I subtract the negative is I'm adding a positive. Look at that. You're actually showing a profit as you move from the 100th unit to the 101st unit. Now, this is some interesting information if you think about it. Even though I am not profitable overall, am I moving in the right direction? I am, because what I'm seeing is that my profit increased $261.97 over what my profit was when I made 100. Okay, so I'm moving in the right direction, and I should have had a clue about that when I saw that the profit for 100 was a negative $9,500 compared to the profit on 101 was a negative $92.38. It's still negative, but it's a smaller negative number. So it means that I'm moving the right direction. I just have a lot of making up for lost time on those earlier units that I've got to cover. Okay, I haven't hit my break-even point yet. Now, obviously, This was tedious. Let me just show you, if we had used those marginal functions, what we would have come up with. So if we took the cost function and we find the derivative, I want you to look back. Your cost function was 32x plus $36,000. What do you get when you differentiate that? Cost was 32x plus 36,000. The derivative of that is just 32. Oh my gosh. That was a much faster way to see what would be the cost. And this is not changing. So if I want to know what would have been the cost of the 100th unit, it's still $32. There's no variable change there. That's staying the same. Now, for the revenue, the original revenue function was 300x minus 0.03x squared. So if we were to find the marginal revenue function, that would be what? 300 minus, and if I pull down the 2, multiply it times this negative 0.03, I get a negative 0.06. Let me erase that. That's a little... Okay. So I would get a negative 0.06x, right? So if I wanted to know what was the marginal revenue for 100 units, okay, then plugging in 100, I would end up with what? If I multiply negative 0.06 times 100, don't I get negative 6? And 300 minus 6 is? $294, isn't it? Yep. Compare that to what we found when we calculated it this way, 293.97. That is pretty darn close, is it not? And on the profit, our profit function that we found was a negative 0.03x squared. Let me move this over a little bit so I've got a bit more room. And that was plus 268x minus 36,000. When you take the derivative of that, we get negative 0.06x plus 268. So if I were to find the profit at 100 units, I get what? 262. I should say the rate of change of profit. I get $262, which also is pretty darn close to 261.97. So using these formulas are so much faster, and they're really pretty accurate. I mean, if you're just off a couple of pennies, that's not going to be a huge deal. Okay, so questions?